this video, we're going to be drawing a ray diagram for a concave mirror. So let's set up a scenario. In this scenario, we're going to determine the position of an image when an object 1 centimeter high is placed 4 centimeters from a concave mirror. This concave mirror has a center of curvature of 6 centimeters. Okay, so let's start by drawing the template as we saw in an earlier video. Now the template consists of a horizontal straight line which we're going to call our principal axis. Upon this, we're going to add all our information. So here's our horizontal line, and I'm going to label it with the words principal axis. Okay, so now I've got to put on a mirror. Now the mirror is going to consist of a vertical line. Remember, it's not necessary to actually draw a curved mirror because it's quite difficult to get it accurate. So let's draw a vertical line there, and we'll label that mirror. Cool. Okay, let's add all the information that's given to us in the question. Alright, now we know that the center of curvature is 6 centimeters. So I measure from the mirror a distance of 6 centimeters, mark a point, and I'm going to label that C for center of curvature. There we go. Now I need to know the focal point. Now I know from my theory that the focal point is half the center of curvature. So if the center of curvature is 6, then the focal point will be 3 centimeters from the mirror. So I put a dot and label it F. So let's just put a note down quickly to remind us that the focal point is half the center of curvature C. Cool. Alright, last thing I've got to add on is my object. Now I know my object is 1 centimeter high and is placed 4 centimeters from the mirror. So I measure 4 centimeters, mark it, and then I will measure vertically 1 centimeter to show the height of the object. Remember, we don't have to draw an object, a simple arrow is good enough, but I always find it useful to label it object as well, just so that I know exactly what's going on. There we go, I'll just label that up, object. Cool, so that's my template finished. Now I can apply the concave mirror laws. Remember, there are 2 laws. So let's work on the first law. The first law goes parallel with the principal axis and then passes from the mirror through the focal point. So I'll just mark off a centimeter high on the mirror so I get an accurate line. I go parallel with the principal axis, and from the mirror it reflects off and goes through the focal point. Notice I put the arrows on to show the direction. Okay, the second law goes through from the top of the object through the focal point, reflects off the mirror, and then goes parallel with the principal axis. Like so. I show my arrows. Where the 2 rays join or converge is where my image will be formed. So I draw a line from the principal axis down to this point. This is now my image. Okay, so now I can have a look at my image and analyze the data. Now I can see here from my image to the mirror, the image is 10.4 centimeters. So I can start writing that down. Okay, so the image position is 10.4 centimeters from the mirror. What's the nature of the image? Well, it's inverted, it's upside down. It's also bigger than the object, so it's enlarged, and it's real because it's on the same side of the mirror. Okay, that's it. Thanks for watching.